Hi guys, good morning. Thank you for tuning in. So today's topic will be timers. Recently, I created a video on timer registers, and the video involved me reading from my data sheet for my particular chip. It also involved reading the general 18F manual, and so I was reading about timers. So that video is available if you go to my PIC programming playlist and look for all these 18F4525 videos, and then scroll down to timer registers, and then I made a similar video on interrupt registers. Well, they are contained in this PIC programming playlist, but those particular videos on timers and registers, timers and interrupts, are not contained in my PIC18F4525 playlist, so you won't find them in this playlist. Those videos were too boring, so I took them back out of this playlist. I know that's confusing, but anyway. So, if I go back to this video 6, part 6 had a very simple program code, and that was while port RA bit RA0 was high, turn on RB0. When a different port A switch was high, send RB0 low. So this had two switches on port A, and it controlled one bit, an output bit on port B, that being RB0. So effectively there is an on and an off switch. Push this one, RB0 goes high. Push RA1, RB0 goes low. Okay, so I generally have a very similar type of program written up here, although it's different. RA0, when it's low, will send RB0 high, and when RA1 receives a 0, it'll send RB0 low. Now when it's a while loop, and what is true in this parenthesis remains true, it'll hang here. And when this is true, the code will hang here. So it won't be true if I sent a high signal into RA0 or RA1. Effectively, I once again have two switches controlling a single port B output, and it generally works the same. And now I will go to my board setup just to show you that this works. I'm building up to something here. I'm going to add some lines of code that relate to timers, but not quite yet. First, let me show you on my breadboard setup that this turns RB0 on and off. Alright, so the green line is RA0, the yellow line is RA1. They're both hooked up to pull-down resistors. When I push a button, it'll send those input pins high. And RB0 is connected here, and currently it's lighting up this LED. So it's basically an on and off switch. I guess that one. Off, on. Well, you get the idea. Okay, so I won't go into too much textbook type explanation. I'm just going to go ahead and make some changes in the code here, and in subsequent videos perhaps I'll get to explaining timers. But for now, I'll just start with an example. Before I even explain anything, I would just like to show that the number 0x87 in hex converts to this number in binary. This is important when looking at the register for the timer 0 register. So I'll try to get this up on the screen at the same time, but 100000111. Okay, so I'm using the paint program here, but this is important. So I'll just keep this handy. Okay, so here I am looking at the T0con timer 0 control register. And I'm just going to show that these ones and zeros are going to correspond to these bits in this register. Okay, so we're going to set a 1 here, here, a 1, 0, 0, and these are all 1s. 1, 1, 1, and this will be a 0, and this will be a 0. So what are we doing setting all these bits on and off? Well, the first bit, bit 7, is going to enable the timer or stop the timer. So by setting a 1 here, we're enabling timer 0. This bit, the T08 bit, configures timer 0 as either 8-bit or 16-bit, and that's a whole separate explanation, which I won't go into, but at present I'm going to configure timer 0 as a 16-bit timer/counter. This next bit here, T0CS, which is the timer 0 clock source select bit, it's getting a 0 as well. That means we're going to use the internal instruction cycle clock. And because there's a 0 here in the TOSE bit, which is the T0 source edge select bit, with a 0 we're going to increment on a low to high transition on T0 CKI pin. Then bit 3 is also getting a 0, and the prescaler assignment we're giving it is 0 bit. Timer 0 prescaler is assigned. Timer 0 clock input comes from prescaler output. Not completely sure I understand all that yet. Even I don't know. And then the last 3 bits are going to set the timer 0 prescaler select bits, and I've selected 111, so the prescaler value is 1 to 256 prescale value. But that's what it means when I've put into my code. I've entered this number here, 0x87 in hex. Just explaining this line of code, why I've set it up that way. Alright, if I paste this in here, this makes sure timer 0 starts counting from 0. I'm basically going to add a delay in here without using that delay, we call that macros or something. I'm going to do it using the timer. And yes, I have some source material that I'm relying on for this as well. And then I'll just paste this in here. And someone's prefigured this number, and it relates to, what do they call it? The divide rate frequency. So someone figured this was a good number. So what this is really saying is do nothing until the count in timer 0 becomes greater than 7,812. So while this is true, don't do anything. When it's not true, then move to the next line. And if the counter keeps counting, it's going to go beyond this number. So really, I don't have enough space to complete my comment, but it's basically saying do nothing until the count in timer 0 becomes greater than 7,812. When this is no longer true, it'll break out of this while loop, or basically when timer 0 becomes greater than 7,812, it will break out of this loop and it will turn port B pin RB0 high. So once again, this sets the timer counter to start counting from 0, and then this while statement says don't do anything while the timer is less than 7,812, but when it's more than that, it'll break out of this while loop, go to the next line, and turn RB0 on. And the way this started is that RA0, so long as it was 0, if it equaled 0, then it would stay in this loop. So if I make this a 1, I send it a high with a push button, it will break out of this loop, and then it'll delay, and then it will turn RB0 high or on. So there's a delayed reaction, a delayed response if I send RA0 a high. And I'll take this same delay, basically what that is, and I'll put a delay after the off switch is pushed. So this is sort of like the on switch, and this is like the off switch. And the same thing happens here. This is a different push button switch going into a different port A pin, in this case RA1. Does it equal 0? The moment I hit a push button and make it equal a 1, this will no longer be true, so it'll break out of this loop. It'll go and make timer 0 start counting at 0. And so long as timer 0 is less than 7,812, which is kind of an arbitrary number, which somebody somewhere else arrived at, if it's less, it won't do anything, but once it reaches this number, this while loop won't be true anymore, and it'll break out of this while loop, and it'll go to the next line of code, and it will turn RB0 off. And I forgot to say at the beginning of this video, obviously I'm doing this in C language. The reason for that is it's way too hard in assembly. Okay, so like I have the word program open here, and I found, I'll be honest, I found some code related to timers as it pertains to PIC18F chips, and I found some code that apparently is reliable and should work, but it didn't. I might try it again. and it's in assembly language. You can see it's a lot more technical than C. So I thought, okay, let's not mess around here. Let's go with something that works. So let's try some C language first before I go back and try things in assembly. What this is supposed to do is basically just blink an LED. But maybe I'll get to this. Maybe. But yeah, today's video is in C language. I should have started off by saying that. Okay, yeah, so now that that's taken care of, I'll clean and build. You can't see that. Did that off screen. The build was successful, so now I will upload this to my PIC18F4525. Okay, that was successful. So in just a moment, I'll be moving to my board setup. And the whole point of this is basically to show that timers can be used as a type of delay. And delays, you can specify the length of time, but you can also do the same thing with timers. Now, without going into more explanation, I think this is more critical when using assembly language, because assembly doesn't really have like a delay macros, if I'm using the correct word, that you can just pop into your program. Assembly language is a little more complicated. You've got to calculate your delay time. Of course, there's different ways to create delays in assembly. So this is getting at building up to creating delays in assembly. Okay, here I go.
Alright, so the point is really just to show that there will be a delay between the button press and the time that RB0 lights up. So here's the RB0 output pin here. So this should be on and off. So press, delay, on, press, delay, off.